8, we're going to talk about solving inequalities in one variable. Now, polynomial inequality takes the form f of x greater than 0, greater than or equal to 0, less than 0, less than or equal to 0, or not equal to 0, where f of x is going to be a polynomial. There's a fundamental connection to inequalities in the positive or negative sign of the corresponding expression. To solve f of x greater than 0 is to find the values of x that make f of x positive. To solve it less than 0 is to find the values of x that make f of x negative. Now, if the expression of f of x is a product, we can determine its sign by determining the sign of each of its factors. Example 1 illustrates that a polynomial function changes sign only at its real zeros of odd multiplicity. So if we look at example 1, determine the x values that cause a polynomial to be 0, positive, and negative. Well, the first things first, we need to make what we call a sign chart. Now, the sign chart we're going to make like this. We know we'll get 0 from the x plus 3 term as negative 3. X squared plus 1 will not have any zeros, and 4 will be a 0. So when we do this, we'll have to put in a number less than negative 3 into the first term. One number less than negative 3 will end up with a negative term. A number less than negative 3 in the middle term will end up positive. A number less than negative 3 here will end up a negative squared. So a negative times a positive times a negative squared will end up being negative. Now, a number in between negative 3 and 4 would be considered 0. So I put 0 into this first term, I'm going to get a positive. If I put 0 into the second term, I'm going to get positive. If I put 0 into this third term, I'll get a negative, but I'm going to square it, so it's going to end up being positive. Now, in the fourth term, or the number greater than 4, I'm going to put that in here, I'll get a positive. In the middle term, I'll get a positive. And in this last term, I'll get a positive squared. So that will be positive region there. Now I know that the negative 3 is going to be a 0 and the 4 is going to be a 0. So for part A, this function is 0 at negative 3 and 4. It'll end up being positive, so for part B, in the region negative 3 to 4 in union with 4 to infinity. And it'll be negative in the region from negative infinity to negative 3. Now I want you to take a moment and work on part B right now. Now again, in this one, we're going to make a sign chart. Our zeros are going to be negative 2, 1, and 5. Now a number less than negative 2 will be negative 3, which means we'll get negative, negative, and negative. Negative times a negative times a negative will be negative. A number between negative 2 and 1 is 0, which means in the first term I'll get a positive, negative, and a negative. A positive times a negative will be positive. Now, a number between 1 and 5 will be, say, 3 will be positive, positive, and negative, which will end up being negative in that region. And then a number greater than 5, they will all be positive. Will be positive here. Now, for part A, where there will be zeros, will be negative 2, 1, and 5. Where it's going to be positive for part B will be in the region negative 2 to 1 in union with 5 to infinity. Where it'll be negative will be from negative infinity to negative 2 in union with 1 to 5. Now, if we graph this, and we put x plus 2, x minus 1, and in x minus 5 into our calculator, you will see from -2 to 1, it'll be positive along with 5 to infinity. And then from -infinity to -2 will be negative. And then 1 to 5, it'll be negative. So you can see that's what's going to happen. And then we'll also have zeros. I'll have a 0 here, here, and here. So there are my zeros. Now our work in example 1 allows us to report the solutions of 4 polynomial inequalities. The solution of x plus 3 times x squared plus 1 times x minus 4 quantity squared is greater than 0 from -3 to 4 and union with 4 to infinity. It's greater than or equal to 0 from -3 to infinity. It is less than 0 from -infinity to -3, and is less than or equal to 0 from -infinity to -3, including -3, in union with 4. This symbol here tells you it's equal to 0 at 4. So this is how we'll write our solution when we get to something like that. Now, example 1 illustrates some important general characteristics of polynomial functions and polynomial inequalities. The polynomial function in example 1 in figure 2.64 changes signs at its real zeros of odd multiplicity, so at -3. It'll touch in turn at x equals 4. It'll have no x-intercepts or sign changes at its non-real complex zeros associated with the irreducible quadratic factor x squared plus 1. Now this is consistent with what we've learned about the relationships between zeros and graphs of polynomial functions from sections 2.3 to 2.5. Now the real zeros and their multiplicity together with the end behavior of a polynomial function give us sufficient information about the polynomial to sketch its graph well enough to obtain a correct sign change without considering the signs of the factors. So when we move on to example 2. So far on this section, all the polynomials have been presented in factored form and all the inequalities have had 0 on 1 or on 1 or of the sides. Examples 2 and 3 show us how to solve polynomial inequalities when they are not given in such a convenient form. So, if we look at example 2, complete the factoring if needed, solve the polynomial inequality using a sign chart, solve support graph. Well, my p's over q's, so my possible rational zeros, all the factors of 24 over all the factors of 2. Okay? What I want you to do is graph this equation in your calculator. So 2x to the third minus 7x squared minus 10x plus 24. Graph that in your calculator. Okay, and you'll see that we'll have 3 zeros that are shown. Okay, it looks like -2 is going to be a 0. So we'll try that one first. Put that into a synthetic division. And simplify. So bring the 2 down, we'll have -4 here, -11, we'll have 22, 12, -24, and 0. Now, it also looks like 4 will be a 0. Okay? So if I put in 4 into a synthetic, we'll have 2, 8, so we'll have this. So if I were to rewrite this, I would have f of x as x plus 2 times x minus 4 times 2x minus 3, which means my zeros would be -2, 4, and 3 halves. So if I were to make a sign chart, I would have -2, 3 halves, and 4. So we're looking at the function here in black. So a number less than -2, let's say -5, which means there'll be negative here, negative and negative, which means I'll be negative. A number between -2 and 1.5 would be 0, which means I'll be positive for the first term in x plus 2, negative and negative for the next two, which means I'll stay positive. Number between 1.5 and 4 is, say, 2, which means I'll be positive, negative, and positive for my terms, which means I'll be negative there. And a number greater than 4 will be 6, let's say, so be positive in the x plus 2 term, positive x minus 4, positive here, which means I'll end up being positive. Now, the original equation said, where is this greater than 0? Well, it's greater than 0 here and here. So my answer will be -2 to 3/2 in union with 4 to infinity. And there's my answer. Okay, there's your answer. Now we can see that on the graph here also. I'm going to take a picture of it. We're going to draw on this. So again, it's greater than 0 here and here. It'll be less than 0 underneath and here. So that's where it's less than 0 there. Okay? So you can see on the graph that's what's really going to happen. Now, at this time, I'd like you to go over B, and then we'll check your answers in just a moment. So please stop the video and work on B. Now, we should see in B that our P's over Q's be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. All of that over plus or minus 1, plus or minus 2, which will really simplify to plus or minus 1, 2, 3, 6, 1/2, and 3/2. If we were to graph this, you'll see from our graph that it does look like -2 works. Put that through its synthetic division. So then you'll get down to something like this. Now, because you know that x plus 2 works, you'll be left with 2x squared minus 7x plus 3 also works. And we want to see where this is greater than or equal to 0. You can actually factor this trinomial here. We know that 2x and x works. We need 7 in the middle. So the only way I'm going to get 7 is if I put 3 here and 1 here, and they'll both be negative. And that means I'll have zeros at -2, 1/2, and 3. So when I create my sign chart, I'll have -2, 1/2, and 3. A number less than less than -2 will be -5, which means there'll be negative, negative, negative. Those will all be negative there. In between -2 and 1/2 would be 0. Positive, negative, negative, which means I'll end up being positive there. A number between 1/2 and 3 is, say, 2, which means I'll be positive, positive, and negative, which means I'll be negative here. A number greater than 3 will be positive, 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 which means I'll be positive here. Now, these are all zeros here in this case. So we're going to actually put brackets on some of these. So where is this greater than or equal to 0? Well, it's greater than or equal to 0 from -2 to 1/2 in union with 3 to infinity. And this is our answer. Now, moving on to example 3, we're going to solve the polynomial inequality graphically. What I would suggest doing, and what I want you to do, I want you to move everything to one side. Now, in these, we're going to have to, again, solve these graphically. So what I want you doing is graphing all these. Graphing the equation. And I want you finding the zeros. So our first 0 will be at 0.325. Our next 0 will be at about 1.46. And our third 0 will be at 4.214. Now, it says, where is this less than or equal to 0? Well, it's less than or equal to 0 here and here. That's where it's less than or equal to 0. So this is the point, 0.325. This is the point, 1.461, and this is the point, 4.214. So our answer will be negative infinity to 0.325, including that since it's equal, in union with 1.461 to 4.214. That's where it would be less than or equal to 0. Now I'd like you to try problem B. So stop the video, try problem B, find your zeros, and find where it's going to be greater than or equal to 0. So what you should have done in problem B, you should have moved your 2x to the other side. We want to see where this is greater than or equal to 0. Now you should be thinking to yourself, hey, I could probably solve this algebraically. So let's do that. We can take out an x. We're left with x squared minus x minus 2 greater than or equal to 0, which can actually be factored again, x minus 2 times x plus 1 greater than or equal to 0. So our zeros will be 0, -1, and 2. Now if you were to graph this, okay, you should see, where is this greater than or equal to 0? Well, it's greater than or equal to 0 right up here. and up here. So your answer will be -1 to 0 in union with 2 to infinity. That's where it's going to be greater than or equal to 0. Now, when a polynomial function has no sign changes, the solutions of the associated inequalities can look a bit unusual, as illustrated in example 4. Solve the following inequalities for the given function f of x. Okay? So what we're going to have here, x squared plus 7 and 2x squared plus 1. So I think the best way to do this would be to graph it. So put it into your calculator. Okay, as you can see, it's just above here. So I'm going to change my window a little bit. Okay, that's what the graph looks like. So where is this graph? Where is this graph greater than 0? Well, it's greater than 0. It's greater than the x-axis everywhere. So from -infinity to infinity. Where is it greater than or equal to 0? Well, it's greater than or equal to 0 everywhere. So from -infinity to infinity. It is not less than 0 anywhere, so this will be no solutions. And it's not less than or equal to anywhere, less than or equal to 0 anywhere, so D will also be no solutions. Remember, we're always looking for above and below the x-axis. Now what I'd like you to do is try example B. So stop the video and try example B. Now, in order to solve example B, we're going to put in here x squared minus 3x plus 3 times 2x plus 5 quantity squared. Okay, what's going to happen? You should see the -5/2, or -2.5, that's going to be your zeros. So where is this thing greater than 0? Well, it's greater than 0 from -infinity to -5/2 in union with -5/2 to infinity. That's where it's greater than 0. Where is it greater than or equal to 0? Well, it's greater than 0 in the same place as here, but then it's equal to 0 at -5/2. So this answer will actually be -infinity to infinity. Where is it less than 0? It's not less than 0 anywhere. So part C again will be no solutions. And then for D, where is it equal to 0? F of x is less than or equal to 0. Your answer will be -5/2. That's the only place on this graph where it's less than or equal to 0. In this case, it will be equal to 0.